Hello, everybody. Welcome to today's lesson. This begins on page 15 in your textbook, and today's lesson is something called piecewise functions. Now, you may have seen or heard of piecewise functions before. Uh, all they are really is they're just regular functions. You can graph them, you can make up tables of values on them, and things like that. But now, instead of just a single function, we have different functions. We can have two, even three, four functions that are all drawn on the same graph. Now, the only thing that's really different about doing that is that these functions, you only graph the pieces for certain domain values. Just look at this right here. There is what a typical piecewise function looks like. All right. Now, that's actually two different equations. All right. One of the equations, the first one, is f of x, which is the same as y, remember? F of x equals 8 minus 2x. Now, you all know what that is. That's a straight line. That's a linear function. That's an equation. But if you look at what comes after that part of the equation, you can see what the domain is for that piece. You only graph this piece for values of x, 0, less than or equal to x, less than or equal to 4. All right, so you only use those values of x in a table of values, say, and plot only those pieces. It does not continue to the left and to the right forever. It has a definite endpoint on each side. All right, but there's a second equation. Now, here's what the second one is. Now, they're still calling it f of x, which is okay. This one is f of x equals 0. Now, that's the same thing as y equals 0. That's basically a horizontal line, isn't that right? But look at the domain for that piece. X strictly greater than 4. So you would plot that piece not using values of x 4 or less. You could use 5, 6, 7, 8 for x. You could even use 4.00001, but you can't use 4. Now, when you graph these two pieces for these two different domains, your graph typically ends up looking something like this one. Something like this one right here on page 15. You can clearly see two separate pieces to the graph, and that's why it's called piecewise. Here is the first piece. Now, that first piece corresponds to this first equation. All right, so you can just make up a table of values, put in values between 0 and 4, and including 0 and 4, into a table of values, and you just plot your points and you get this piece. The second equation, y equals 0, or f of x equals 0, remember that's a horizontal line. It actually intersects the y-axis at 0, which kind of means it's the x-axis, isn't it? But that's only plotted for values of x greater than 4. That would correspond to this piece right here. All right, so it's like two separate pieces on the same graph. Now, in this case, the two pieces look like they actually intersect. They actually touch each other at that point right there. And that's fine. That just means this graph is what we call continuous. But it's quite possible that the two pieces may never actually touch each other. All right? So that's what we call piecewise functions. And you can get domain and range from piecewise functions as well. The domain basically is just these two things put together. That's what your domain is. And if you look carefully at your graph, you can even see what the range is, okay? So in this case, the domain would be, now let me see, where are the x's? How far to the left does this go? How far to the right does this go? Well, you can see that it ends off right there. That's the smallest x value. That's 0. And where does it go? Well, let me see. According to this domain up here, it says x is greater than 4. So that graph there, that piece of the line, actually does go up to infinity. So here's your domain in this case. It's values of x such that x is greater than or equal to 0. X belongs to the real numbers. Now for the range of these pieces, it's the same thing as saying how far up does the graph go and how far down does the graph go. Well, let me say, those two pieces, there's the highest. That's as high as it gets. And that's got a y value of 2, 4, 6. That's got a y value of 8. How far down does the graph go? Well, let me see. Right there, look. That's the smallest it gets. And that's got a y value of 0. So again, the way you would write that, all the values between 0 and 8, including 0 and 8, would look like this. 0 is less than or equal to y, which is less than or equal to 8. Y belongs to the real numbers. So there's your domain and your range. Now let's look carefully. I'm going to do one more example of these with you. Probably this one right here. Practice number 5 on page 16 on the very top. So here's your two functions again. You see that? There's going to be two pieces here. The first piece is just y equals 2x. Actually, let me write it down here, because I'm going to make a table of values and show you what numbers you should put in. So there's your first function. But you only graph it for values of x that are strictly less than -1. That's what this piece here means. And the other graph, and I'll put this over on the right-hand side. The other piece is going to be y equals x plus 1. I think that's just a straight line as well. They're both just straight lines. But that piece you only graph for values of x greater than or equal to -1. Okay, well, that don't look very good. But anyway, that's my pen. Sorry about that. So here's what we're going to do. Watch this. Watch very carefully now. So all I'm going to do is make up a table of values, x and y. And here's the table of values for this function on the left, and I'm going to make a different table of values for the function over on the right. Okay? Now, notice that the domain here is less than, or sorry, not equal to, just less than -1. But you should include the -1, even though there's not going to be a point there, because it is kind of an endpoint for this piece. But because -1 is not actually on that piece, you might recall this as well, we use a hollow circle for that point there, indicating that that point is not actually on that piece. And put in some other values now that are less than -1, like -2, -3, -4. You can go on down as far as you want. Put those numbers now into that first function. If I put in -1 for x, 2 times -1, I get back -2. But remember, that's going to be hollow. I'll even put that right here. Look, that's going to be a hollow dot because -1 is not actually included in the domain for that piece. -2 is though. Put in -2, 2 times -2, you get back -4. Put in -3 for x, you're going to get back -6. Put in -4 for x, you're going to get back -8. I could continue with that table on down, but I think that's probably enough. Okay? So what does this look like? Well, -1, -2, find that on your graph, but do not use a solid dot. -1, -2 right there, use a hollow dot. Okay, hollow, because -1 is not actually in the domain for that piece. It's in the domain for this piece over here you see on the right, but not the piece on the left. So -2, -4 would be right there. Now that's a solid dot this time. -3, -6 is right there. -4, -8 is right there. And you can see it's linear, as it's supposed to be. Now, I don't have a ruler that I can use here. I don't have a straight edge, but you please make sure that you use a ruler or a straight edge for this. And you just draw your line from the hollow dot down through those other solid dots, and you put an arrow on the end. So that indicates it goes down forever and ever and ever, which it does. Let's go to the other piece, y equals x plus 1. Now, this time I have to use x values greater than or equal to -1. So I include -1 again. But now I also put in x values greater than that. So like 0, 1, 2, 3. You can put in as many as you like there. Let's put those into that second function. So if I put in -1 for x right there, I get -1 plus 1. I get back 0. If I put in a 0 for x, I get back a 1. If I put in a 1 for x, 1 plus 1, I get back a 2. If I put in a 2 for x, 2 plus 1, I get back a 3, and so on. Put in a 3 and I get back a 4. So this time, when you graph this piece of the line, there are no hollow dots. They're all solid. -1, 0, everybody, is right there. Look, and that's solid now, not hollow. 0 and 1 is right there. 1 and 2 is right there. They're all solid now, remember. 2 and 3, right there. 3 and 4, right there. You can continue this as far as you want. Now, take your ruler. Make sure you use a ruler for this. And this piece of your line should look something like that. And again, that goes on forever on the other side. Now, notice that these two pieces, this is a piecewise function, these don't touch each other. They don't intersect. And that's fine. That's absolutely okay. All right? That happens a lot. Not to worry. Now, what would the domain and the range be for this? Well, remember the domain is your x values. Basically, if you put this piece here together with this piece here, what x values are on those two lines? Well, it's the same thing as saying how far left, how far right. This piece of the graph goes on up to positive infinity. This piece of your graph goes on down to negative infinity, to the left. All right? There is no break in between. -1 actually is included in your domain because it's in this piece right there. So your domain is all real numbers. There's your domain. Okay? Now, what about the range? That's a little different. That's a little trickier. You better be careful. Remember that the domain means how far left, how far right, but the range basically means how far up and down does your graph go? Are there any breaks in between those two pieces? I think you might have breaks here. This piece right here on the right, okay, look at that piece on the top. Notice that the smallest y value on it is 0, and that's right there, but it then basically shoots up to positive infinity. So from 0, including 0, and up, that's in your range. Now, what about for the other piece? This piece over here on the bottom. Well, you can see it goes down to negative infinity, but it only comes up to here. You see that? -2. And it's not actually including -2 because that's a hollow circle there. So this piece, basically, this piece right here on the bottom, starts at -2, but not including -2, and goes down to negative infinity. So here's what you would have to write for your range there. Where can I find some space? Let me clear up some things right here so I can free up some space. Okay? Okay, so here we go. Here's what your range is now for this piecewise function. You have to basically write it, in this case, as two separate pieces. The bottom piece, it doesn't matter which one you put first, but the bottom piece is y strictly less than -2. You see that? And then I put a comma there. That takes care of the bottom piece. The range is strictly less than -2 and not equal to -2. The top piece is greater than or equal to 0. So I write greater than or equal to 0. Notice two separate restrictions, and that's fine. But what kind of numbers? Well, because it's a continuous line, all real numbers, because all the decimals are there, all the fractions are there, all the piddly little numbers in between. And there's your range. Okay, so you have to look carefully. You basically do need to look at your graph of the piecewise function carefully to get your range. And that's how we do piecewise functions. So now you try the other ones. You try the practice questions. There's B on the bottom of page 16. Then practice number 6 on the top of page 17. Now here's a little thing I need to point out very quickly. I've only got about a minute left. What if you were asked to evaluate a piecewise function for a certain number? Okay, now you can see this piecewise function, there's actually two pieces to it. There's two parts to it. Well, which part do you put your -1 in? Do you put it in the top piece? Or do you put it in the bottom piece? Well, it all depends. Look at your two domains. Look at the domains for the top piece and the domain for the bottom one. Which of those domains does -1 belong in? Is -1 less than or equal to 2? Or is -1 between 2 and 5? 2 is less than x, which is less than or equal to 5. Well, actually, -1 belongs in the top piece, doesn't it? So when you're evaluating -1, that's where you put it, only in the top piece. That becomes 1/2 times x plus 4. Well, I'm almost out of time, so that's 1/2. I should have put a -1 in there. -1 plus 4, so that's 3/2, I believe. 3/2, I think, is what you get back. So I'll stop there. Video is over. Bye-bye for now.